In this video, we are going to be looking at using two exponent rules to simplify an expression. Number 20 asks us to simplify 9x cubed y to the second divided by 3xy squared, all raised to the third power. So one thing that you can do for this problem is that you can work on the inside, clean it up, and then use the power rule to get rid of the 3. Or you can get rid of the power of 3 first and then clean it up by simplifying it. So I think it's easier to start on the inside, because when I start on the inside, I'm going to be making it little first. And in math, you'll find that it's always easier to make something little first and then big. So the first thing that I'm going to do is I'm going to use the quotient rule and make that expression smaller. So the quotient rule tells me to subtract my exponents of like bases. So in this expression, I have coefficients, I have bases of x and y. So when I clean it up, it'll be clean on the inside, but I'll still have that power of 3 on the outside. So starting with the coefficients, 9 divided by 3, that's 3. And it's a whole number 3, so I'm going to keep it on top. Remember, there's an understood denominator of 1 under these numbers. All right, now I'm going to move on to my x, base of x. I have more x's on top, so I'm going to write my base of x on top. 3 take away 1 is 2. Now moving on to my y's, I've got 2 y's on top and 2 y's on the bottom, so they cancel each other out. So I don't need to have anything to do with my y's. Now I'm going to look at this outside power and get rid of it. So that's the power rule. Now if I don't see an exponent, I know that there's an understood exponent of 1. So the 3 has an understood exponent of 1. So when I pass out this outside power, I end up with 3 to the third, x to the 6th. And then of course I want to simplify 3 to the third. 3 to the third is 27. So I have 27x to the 6th. Number 21, we have 3a to the 10th, b to the 11th, divided by 18, a to the 2nd, b to the 20th, all raised to the 2nd power. So again, we have coefficients, bases of a and bases of b, all raised to the 2nd power. So I'm going to make it little again, because it's so much easier to make something little first and then make it big. So looking at the 3 and the 18. Well, because my smaller number is on top, then I know that it's going to stay a fraction. So what can I do for 3 over 18? Well, I can divide them both by 3 and reduce that fraction. So 3 over 3 is 1. And 18 divided by 3 is 6. So that fraction reduces to 1/6. Now I'm moving on to my base of a. I have more a's on top, so I'm going to write the result on top. 10 take away 2 is 8. Moving on to my b's, I have more b's on the bottom, so I'm going to write my result on the bottom. And 20 take away 11 is 9, and they are all going to be raised to the 2nd power, all my bases. So one thing to keep in mind is that this 1 that's in front of the a is not needed. It's only needed when you don't have anything else up in the numerator. So now I'm going to take this outside power and give it to all my inside powers. Now 6 doesn't have a power, so I'll put that power of 1 there. And we're going to use the multiplication operation to do that. So we're going to keep the base of a and then multiply. 8 times 2 is 16. Moving on to the 6, keep the base of 6 and then multiply. 1 times 2 is 2. And then for the b, keep the base of b. 9 times 2 is 18. And 3 to the 2nd power, 6 to the 2nd power simplifies to 36. So in the numerator I have 8a to the 16th over 36b to the 18th. Now again, on these particular examples, the first and the second one, you could get rid of the outside power first and then make it smaller by using the quotient rule. But it's really a lot easier to make something little first and then big. All right, now 22, we have 4a squared b raised to the third power times 5ab to the third. Now in this particular example, we don't have a choice. We have to get rid of that outside power first by multiplying that outside power by all the inside powers. So keep in mind the 4 and the b have inside powers of 1. So I'm going to keep that base of 4 and then multiply. 1 times 3 is 3, so 4 to the third. Keep the base of a, 2 times 3 is 6. Keep the base of b, 1 times 3 is 3. But 4 to the third needs to be simplified because I have to multiply. 4 to the third is 64. So this is 64, a to the 6, b to the third. And it's going to be multiplied by 5a b to the third. So that was the power rule, getting rid of that outside power. Now I'm going to go on to the product rule that says multiply your coefficients and add your exponents of like bases. So I'm going to multiply 64 times 5, which is 320, and then I'm going to add my exponents of like bases. So keep in mind that this a has an understood exponent of 1. So I'm going to end up with a, 6 plus 1 is 7. Moving on to the b's, 3 plus 3 is 6. So we have 320, a to the 7th, b to the 6th. 23, we have negative s squared t times negative 3s squared t raised to the third power. So this time I have to start with the second parentheses and get rid of that outside power. So remember that we have to give this outside power to all the inside power. So I'm going to put a 1 on the 3 and the t. So this means for looking at my coefficient, I have negative 3 times negative 3 times negative 3. So I'm doing this all together because of that negative. So negative 3 times negative 3 is a positive 9 times negative 3 is negative 27. So that simplifies to negative 27. Now I'm just going to multiply the other two powers with the outside power. So we end up with s, 2 times 3 is 6, and then t, 1 times 3 is 3. Now I'm going to bring down the other parentheses, which is negative s squared t, and multiply those together. Now remember there's an understood 1 behind that negative. So I'm multiplying a negative 1 times a negative 27, which is 27. And now I'm going to keep my bases and add those powers. So keep the base of s and add my powers. 2 and 6 is 8. The t has an understood power of 1 for the first parentheses. Keep the base of t and then add the powers. 1 plus 3 is 4. All right, so sometimes it's tricky when you've got those two rules at once because you have to change gears and remember what that rule says to do with those exponents, whether you're adding them or multiplying them. So you always have to be mindful of what you're doing.